Hi guys, today we are going to continue on with doing our notes from chapter 3. We did carbohydrates yesterday and now we are going to spend the day talking about lipids. So here are two different fatty acid chains and you'll notice that there are some slight differences in there. This one, for example, has all single bonds and this guy over here has a few double bonds. It looks like he is missing hydrogens. We'll get to that part in a second. Let's start off with the basics. Lipids are comprised of carbon, hydrogen, and oxygen, but the ratio of hydrogen to oxygen is much higher than the 2-to-1 ratio found in carbohydrates. So we no longer have that 1 to 2 to 1 ratio. Notice that there are only 2 oxygens in a lipid. It doesn't matter which kind of lipid you're talking about, they only have 2. So we don't have that ratio anymore. Lipids are going to store large amounts of energy because of the high number of carbon-hydrogen bonds. So the more bonds you have, the more energy you can store. Lipids are also large, non-polar molecules. Think about what non-polar means. Remember, water is polar, and it can dissolve other polar or ionic substances. Cannot dissolve non-polar, though. The monomers of most lipids are going to be called fatty acids. And hopefully you're writing down the stuff in blue again. I know it seems like a lot right now. Don't worry. I'll stop in a second. There you go. A fatty acid consists of a long hydrocarbon chain with a COOH or a carboxyl group at one end. So the black part you don't write down, the blue part you do write down. The hydrocarbon end of the fatty acid is hydrophobic or water-fearing because it is nonpolar. It's going to repel water. So the hydrocarbon end, remember hydrocarbon means hydrogen and carbon. So we are talking about this big, huge section, all of this, the tannish part, that is hydrophobic. It's scared to death of water, hates it. It's nonpolar, meaning that you can't dissolve that in water either. The carboxyl end of the fatty acid is hydrophilic or water-loving because it is polar and it is attracted to water. So this little pink part is going to be attracted to water. I used to have you guys draw these structures out. Please don't worry about that right now. I don't even want to think of how much time it would take you to actually draw out a hydrocarbon chain there. So we'll just go with the parts in blue that you're writing down. So in a saturated fatty acid, carbon is going to form 4 single covalent bonds with other atoms. The carbon atoms are saturated with hydrogens. That means that they have the maximum amount of hydrogens that they can possibly have. In most cases, that's going to be 2 bonds with hydrogen. So each carbon is going to bond to another carbon and 2 hydrogens. Except for this last guy down here. He's going to get 3 hydrogens and just 1 bond to carbon. So that is completely saturated. You should see 4 single bonds. Oh my gosh, that hamburger looks so good right now. That contains a lot of lipids and a lot of carbohydrates. And even some protein in there. Could you imagine eating that huge hamburger? I haven't seen this guy on the Travel Channel in a while. I'm not sure if he's still around or not. All right, let's get back into it here. The other type of fatty acid chain is unsaturated. Some carbon atoms are double bonded to other carbon atoms. These carbon atoms are not bonded to the maximum number of hydrogen atoms and are therefore considered unsaturated. So not every single carbon is going to be unsaturated, but at least one of them is in the chain. So if you look over here, this is a double bond. Notice that there's no hydrogen in those spots, so it kind of looks like it's missing something. And, well, it is. But carbon already has 4 bonds, so it's not possible for it to bond to another hydrogen. As long as there's 4 bonds, carbon is happy. Lipids are divided into 4 categories, and that's according to their structure. Classes of lipids are going to include triglycerides, which are your fats and oils, phospholipids, waxes, and steroids. The triglycerides, we'll do those first. If you remember back to that picture with the fatty acid chain, and I told you about the saturated lipids, that is going to be a saturated triglyceride. These fats are going to come from animals and are solids at room temperature. These are the ones that are not good for you. If you have ever chewed a steak and you got that, I hate steak because of the fat. But if you get that in your mouth and it's like chewy and disgusting and it makes you want to vomit, that is a saturated fatty acid. They're bad for you. Unsaturated triglycerides are going to be the ones that have the double bonds. These are oils. Usually they come from plants, and they are usually liquids at room temperature. Coconut oil is an exception to this because it can be a solid, but those ones are the healthy ones for you. So if you use an olive oil, that's really good for you. So here is some olive oil. You know, you're going to squeeze a bunch of olives to get it, or grapes maybe. This is grapeseed oil. You'll squeeze the grapes. For peanut oil, you're going to squeeze peanuts and get oil out of those. So if olive oil is made of olives, then what is baby oil made of? Definitely don't want to squeeze babies. You'll get something out of them, but it's not going to be oil. Next kind is a phospholipid. Now, phospholipids, they make up the cell membrane, and the cell membrane is going to be composed of two layers of phospholipids, which is often referred to as the lipid bilayer. This material is very effective as a cell membrane because it is insoluble in water, which is usually inside and outside the cell. So here's what a phospholipid looks like, and here's the two fatty acid chains. So this would be outside of the cell, this would be inside of the cell. There's water in and out of your cells, and the pink part here, the phosphate head, loves water, so it's cool with touching the water. But these little tails, they're actually going to intertwine with one another, and they are going to keep the water from crossing the barrier. So the water that's outside of the cell has to stay out. The water that's inside the cell will have to stay in. Waxes are highly waterproof. If you ever had braces, they probably gave you wax to put on the back of that metal wire that they shove in your mouth until you could get it cut off because it pokes your lip or your cheek. They do that because wax is very waterproof. Also in candles, if you ever submerge a candle into water, the water is just going to beat up. That candle is not going to be really affected by the water. Waxes form protective layers in both plants and animals. In plants in particular, they have a cuticle on the outside of their stems, and that keeps water inside of the plant. So if it's a really hot day out, the plant is not automatically going to lose all of its water and die. Very important for plants. People have earwax. We don't have protective layers like plants do, but earwax actually does serve a purpose for us. It's supposed to protect your ear. If you get too much of it built up, it can cause some problems with hearing, so you can go to the doctor and they can remove it. I've seen some really interesting videos of candling, which I've never tried, never had done, but it looks kind of cool. They use like a flame and somehow that draws the wax out of your ear. I don't know. I clean my ears pretty regularly. In college, I cleaned them way too much. I was a little obsessed with cleaning my ears. I don't know why. And I ended up hurting my eardrum a little bit. And the membrane in there, I had to use ear drops because I irritated it so bad. So really be careful with cleaning your ears. The last type of lipid is a steroid. Most people don't think of steroids as being lipids, but they are. Examples of this would be hormones found in humans like cholesterol or the sex hormones testosterone and estrogen. And that is where we are actually going to stop today because now we are getting into proteins. Alrighty guys, I'll see you later.